So, hello everyone, I am Sharat Chandra. So, this is I am giving the demo of quadratic equations. First of all, as you people have already studied in class 10th standard, so this is not a new chapter for you all, but in the 11th standard also, this is just a modification of the what you have studied all through the 10th standard. And here, this thing is not very difficult, not very complicated. It is very easy, but every year 4 marks for the JEE is all assured from this chapter, and for the school examination, this is a very school point of view. This is a very important question. So let's have. So first of all, we will revise with whatever we have gone through the previous class till now. So what is quadratic equation? Quadratic equation is nothing but polynomial of second degree. So ax square plus bx plus c equal to 0 is a type of polynomial, is a quadratic equation where definitely a should not be equal to 0. And what are the roots of equation? X is equal to minus b plus minus square root of d upon 2a, where d is b square minus 4ac upon 2a. D is discriminant. You people have already gone through these things in your previous classes. So there is nothing new. So when there is a quadratic equation, it has two roots, alpha and beta. So from here we see plus minus. So alpha can be written minus b plus root d upon 2a, and beta can be written as minus b minus root d upon 2a. Now the thing is, sum of roots and product of roots. What is alpha plus beta is when you add minus b plus root d upon 2a plus minus b minus root d upon 2a. So denominator are same, so these things will be cancelled out. So we get finally minus b upon a. And the product of, and apart from this we see product of roots, that is alpha and beta. So what this is going to be? This is just minus b plus root d minus b minus the square of root d upon 2a into 2a. So it will be nothing minus b square minus root d square upon 4a square. So now we can see that minus b square is nothing b square minus d, and d is what is d? D is b square minus 4ac. So when we do b square minus b, it will be 4ac upon 4a square. A cancels out, 4a cancels out. So finally it is c upon a. So alpha beta is c upon a, and alpha plus beta is minus b upon a. So here we see sum of root is minus b upon a and product of root is c upon a. Now here we have a new something new which lot of people are not paying attention to, that is difference of the roots, that is alpha minus beta. What is the magnitude of difference of roots? So we have seen this is minus b plus root d upon 2a minus b minus root d upon 2a, magnitude. So minus minus will be plus, so this thing will get cancelled, and this root d will become twice of root d upon 2a. So this thing will be magnitude, as it is already the square root, so it will be square root of d upon a. So basically the difference of roots will be equal to root d upon a. this is very important. See, this concept is very important because a lot of times the questions have been asked, the objective questions in the multiple times have been asked from directly from this concept. This question is given and directly the option is given. If you have done this, then you can directly figure it out with the option. Now we will just do a new one question of this concept, then we will proceed with other topic. I hope this is not very difficult. Now we are going to proceed with another question. Question is we are given with two quadratic equations, ax square plus bx plus c is equal to 0. The roots are alpha and beta. Now and another two, ax square plus bx plus c. The roots are alpha plus delta and beta plus delta. And we have to prove that b square minus 4ac upon a square is equal to capital B square minus 4ac upon a square. Now, how can we do this? Now, just see, we have been given only two equations. Only the coefficients varies with their uppercase and lowercase value, and the roots are alpha, beta, and another root are alpha plus delta, beta plus delta, and we have to prove this thing. So, what we are going to do in the first question, what is the difference of the root is going to be alpha minus beta is going to be root t upon 2a, as we have seen earlier, and root t upon a. So, and it will be basically root under b square minus 4ac upon a. And from the second we can write as alpha plus delta minus beta plus delta. It is equal to, and this thing will be equal to root under b square minus 4ac upon a. Now we see delta gets cancelled. So overall mod of alpha minus beta is equal to square root of b square minus 4ac upon a. Now we can name it as equation 1. This can be as equation 2. Now when we equate both, when we are equating both 1 and 2, we see root under b square minus 4ac divided by a is equal to square root of b square minus 4ac upon a. When we square both the sides, we get b square minus 4ac upon a square is equal to b square minus 4ac upon a square. Now, so hence proved. This question was asked in one of the engineering examination, and most of the people were unable to do, just because that concept of difference of roots is rarely taught or is not taught by everyone. So this thing was a little bit difficult. But once you know the previous concept, so you can go through this question very easily. Now next topic is about the nature of roots. Firstly, we will revise with formation of roots. So as we know, we have, if we are given with alpha and beta, the equation will be x square minus alpha plus beta x plus alpha beta is equal to 0. So this we all know. Now the next topic is location. Next topic is the location of roots. Sorry, the location of roots is next. This is nature of roots. Nature of roots. So, firstly, as we see, is ax square plus bx plus c is equal to 0. If this is the equation, so now there are several conditions. First of all, a should not be equal to 0, as we have already mentioned. If a is equal to 0, this will be a linear equation, not a quadratic equation. Secondly, now condition is first of all, if the condition is d is greater than 0, and if a is greater than also 0, then the nature of roots will be, the graph will be something like this, and roots will be real and distinct. Second, if d is equal to 0, the roots will be equal. Third, if d is smaller than 0, then the roots will be imaginary. In this case, the graph will be like this. In this case, the graph will be like this. One thing, the major point to be noted here is, if d is greater than 0, but again there is two cases. If d is a perfect square like 25, 36, 49, so on. If d is a perfect square, then the roots will be distinct. Roots will be set of cube, means it will be some natural number. It will be some natural number or some fractional rational numbers. But if d is not perfect square, then roots will be of the form of p plus root q and p minus root q. And in this case, when d is smaller than 0, the roots will be in the form of p plus iota q and p minus iota q. So this is one major point in this. When d is greater than, discriminant is greater than 0, if discriminant is a perfect square, then roots will be distinct and it will be a rational number. If discriminant is not a perfect square, in that case also the roots will be rational number, but it will be in the form of p plus root q, p minus root q. And if the discriminant is smaller than 0, it will be p plus iota q and p minus iota q. Nature conjugate of complex numbers. So these are called conjugate. The next topic is maxima and minima. So suppose we are given with the ax square plus bx plus c is equal to 0, and we are asked to find the maximum and minimum value of this equation. So as we all know, if a is greater than 0, the graph will be something like this. If a is smaller than 0, graph will go something like this. So if a is greater than 0, the range it will have some minima, and if a is smaller than 0, it will have maxima. This point will denote maxima, and a is greater than 0, it will denote the point of minima. Now, how to find the maxima and minima? There are two methods. Either we can find it by making the perfect squares, or else right now we are matured enough to do a little calculus and we can just differentiate and get the value of maxima and minima. Just differentiate the value, differentiate, then to equal to the 0. So let's say y is equal to ax square plus bx plus c. Y dash is equal to 2ax plus b, and y double dash will be equal to 2a. So if a is greater than 0, in this case y double dash is greater than 0. So if it is greater than 0, it means it will give minimum value. So, and in this case y double dash will be greater than 0. It means it gives maxima. So for getting the minima or maxima, we have to equate this 2x plus b is equal to 0. So x will be equal to minus b upon 2a. So value of x at this point will be minus b upon 2a, and the value corresponding to this will be root d upon ax square plus bx plus c. The value of x is minus b upon 2a. So we can write x minus b upon 2a whole square plus b bracket minus b upon 2a plus c. This can be rewritten as ab square upon 4a square, a cancels out, minus b square upon 2a plus c, which gives us b square minus 2b square plus 4ac divided by 4a. So minus b square plus 4ac divided by 4a. It can be written as minus, can be taken common, minus b square minus 4ac upon 4a. Now this is nothing but minus d upon 4a. So here in this case it can be written as minus d upon 4a as a minima, and the maxima here will be minus b upon, sorry, this marker is not working. Minus b upon 2a, comma, minus d upon 4a. So this is the nature of maxima and minima. Now the next thing is cubic equation. Is it cubic equation? This is not a part of quadratics, but this is also important because sometimes the questions may be asked from this topic. So we see just for sake of revision, we can write this is just similar to quadratic only. Ax cube plus bx square plus cx plus d is equal to 0. Now it has three roots: alpha, beta, gamma. So here again alpha plus beta plus gamma is minus b upon a. Alpha beta plus beta gamma plus gamma alpha will be c upon a, and alpha beta gamma is minus d upon a. So what we have to do, just when we take the roots singular, when we just add the three roots, the second term upon first term will be appearing. So this is plus minus. We will take the sign consecutively. So at the second, when we go for the second term, we will have to take two of the roots combinedly. So c upon a plus, here this term minus was used, so here plus will be used. C upon a. Thirdly, we will take all the three terms combined, alpha, beta, gamma, minus b upon a. So I think this one is done for today. So we will take the next topics are the location of roots and all the location of roots, and further things are there. But the question is, nature of roots is always more important than any other topic. Location of roots is secondary nature of interest for this specific topic. So we will take this in the next lecture. Please, that's all for today. Please give me the feedback what you have felt till now. We will continue with the next topic.